back to science class. In the previous class, we have started the 12th chapter, that is electricity and electric circuit. Okay, in part 1, do you remember what you learned? Yes, we have learned electricity, right? What is electricity? Electricity is the flow of electron. Okay, and second we were discussed from where you get electricity. So we have concluded that from power station, the electricity will come up to the substation. From the substation, it will reach us to different electric line, and finally we can consume the electricity, right? So after that we will discuss electric cell. So what is electric cell? Electric cell is a energy producing source. Okay, a minute amount of electrical energy can be produced by using a electric cell. An electric cell has two terminals. The first terminal is the positive terminal, is a metal cap, and the negative terminal is the metal disc. Okay, so we will concluded that two terminals of electric cells. So if you connect more than two cells together, you can make a battery. Okay, so what is the difference between cell and battery? If cells are joined together, you can make a battery. So battery can produce more voltage of electric current than cell. Okay, these many points we were covered in the part 1. Today we are going to the part 2 session. We are going to study the topic electric circuit. So children, what is electric circuit? Electric circuit is nothing but it is a closed path where the electric current can flow through the closed path. Okay, let's study in detail regarding electric circuit. Electric circuit is a closed path. Okay, remember the point, closed path along which electric current can flow. It should not be open, it's a closed path like this. Okay, always it is closed path, it should not be like this. It should be closed and electric current can flow through the closed path of the, closed path. Okay, so how to make a simple electric circuit? Okay, in order to make a simple electric circuit, you require electric cell, bulb, wire, etc. Okay. Okay, the same picture which is there in your textbook also. So you know that the positive terminal of the battery is the metal cap. Okay, the positive terminal of the cell is a metal cap, and the base part is the negative terminal. Okay, so you should connect two wires. One wire from the positive terminal and the other wire from the negative terminal. So when you connect like this, you will get two free ends. So after that you can see the torch bulb. Okay, the positive part of the torch bulb and the negative part. Okay, this you have learned in the part 1. Okay, so you will get two free ends also. The bulb which will be again connected with the two wires. So that time again you will get two free ends. So what happens? The two free ends of the cell should be connected to the two free ends of the bulb. So that what happens? Yes, electricity can flow from one part to another part. Look at here. It will reach from one part to here. From there again it will reach from this part to this part. The electricity will be flow in a circular path. Okay. This picture you can see in your textbook also. Okay, you can see the connection of the bulb. How the electric circuit is connected. You can see the arrangement A, B, C, D, E and F. Out of this 6 arrangement, you can see only A and F will be working properly. So what happens to F? How is F glowing? Even though the connection is different in terminal, the thing is that one wire should be connected to the one terminal and the second wire should be started from the second terminal. Then only the current can flow through in a circular path. So that is why A and F is glowing properly. Okay. So look at here. How the A and F is glowing. Here the connection is proper. No breakage of the electric current. Okay, here no breakage of the electric current, and you can see that this will be function. You have already learned how F is working, means the filament. Okay, the filament is connected to this terminal, base of the bulb, as well as the metal tip of the bulb, right? Metal tip of the base. So when you connect like this, what happened? The two terminal is connected to the two different parts, so that F can be easily glow. Okay, the positive terminal should be connected to the one part, the next part should be connected to the next terminal, right? Here the filament is there, from the next part you can see the second connection is started. Okay, so when you connect like this, you can see that the bulb will be glowing. Okay, the filament have two terminals. Okay, positive to bulb, from the second terminal again it is connected to the negative terminal. Look at here. Here also, even though the connection is entirely, it is changed also, the bulb can be glow, because the two terminals were connected. The wires are connected in a two terminal. So the filament also connected in the base of the filament bulb also connected with the base of the bulb, as well as at the cap of the bulb, so that it can easily glow, and the circuit is complete even though there is no breakage of current. Okay, the bulb will glow easily. Okay, there are two types of circuit. The one which is closed circuit. So in closed circuit, no break in the path of the current. From one terminal to other terminal of the cell. And what is open circuit? There should be break in the path of the current. In the open circuit, electric current cannot flow, but in closed circuit, electric current flows. Okay, remember the point? The circuit should be closed. Then only what happens? Yes, the electric current will flow in a circular path. Okay, then only the bulb will be functioning. But if it break, look at here, if it break in the path of the electric current, which never glows. Okay, which never glows. Okay, that is the difference between closed circuit and open circuit. Okay, I hope you understood the differences between those two. Okay, once you look at the diagram, you can easily understand which current will flow, which will not flow current. Okay. Now let's study a fused bulb. Okay, an electric bulb may fuse due to many reasons. The one reason for a bulb to fuse is break in its filament. We used to say that the filament is gone, the filament is gone. A filament can be break. Okay, a break in the filament of the electric bulb means a break in the path of the current. Okay, the current path is break. So in between the two terminal, the current should be flow, right? This two terminal, the current should pass. It should reach this terminal, and it will start to glow, and from there again it should be connected to the other terminal, right? From there it should be connected to the other terminal. So then only the circuit is completed, then only the filament will work out. Okay, now if you want to work a torch, okay, the same principle should be work. Okay, or else the function of the bulb, the filament will be gone. Okay, that point you have to remember. Now let's go to the homemade torch. So children, what is homemade torch? If you have a cell like this, or if you connect it with a wire and an electric switch, you can simply make a homemade torch. Okay, fix the other end of the wire to the negative terminal of the electric cell with a rubber band. Just a rubber band is there to fix it. Now bring the tip of the base of the bulb, that is its other terminal, in contact with the positive terminal of the bulb. Okay, will the bulb glow? If it connects two terminals properly, then the bulb will glow. Or if it connects not properly, means it never glow. Now we will move to study the electric switch. When the switch is on, electric appliances work. When the switch is off, appliances does not work. What happens when you switch on? The circuit get complete, the current will flow. When you switch off, what happens? The circuit is break, the current doesn't flow. So what is the role of switch? A switch is a device that either breaks the circuit or complete it. If the circuit is complete, then it will be work out. So without switch, a circuit never complete. The switch is on position, then only current will flow. Now let's study in detail by making a switch. How to make a switch? We can make a switch using 2 drawing pins, a safety pin, 2 wires and a small sheet of thermocol or a wooden board. So insert a drawing pin into the ring one end of the safety pin and fix it on the thermocol sheet. Make sure that the safety pin can be rotated freely. Okay, this should be rotated freely. The safety pin is actually acting as a switch over here. Now fix the other drawing pin on the thermocol sheet in a way that the free end of the safety pin can touch it. Okay, so what happens? This is the one end, okay, which is connected to the bulb. So look at here. This is a simple circuit diagram. The safety pin is acting as a switch over here. Once the safety pin is closed here, when it is touched means the circuit should be completed and the bulb will be working, because once the safety pin is removed from the second nail, what happens? The breakage, the flow of current is breakage. Okay, no supply of current. The electric current cannot pass through this area. So that time the bulb will not glow if you do like this. But the bulb will glow if the safety pin is closed. Safety pin, here the role of safety pin is a switch. Here the safety pin is acting as a switch that allows to pass electric current to the next terminal. So once the safety pin is in the open mode means the electric current cannot pass through this, the next terminal of the battery, and the bulb does not work. So the safety pin covered the gap between the drawing pins when you made it touch 2 of them. In this position, the switch is said to be on. Okay, since the material of the safety pin allows the current to pass through it, the circuit was complete and hence the bulb glows. Okay, in this case the bulb will be glows. Here you can see what happened, the preparation of a simple switch and with the help of a safety pin, how does it work. Okay. Now let's study working of a torch. So you can see inside the torch, inside view of torch, you can see 2 electric cells were there. Okay, this is 2 electric cell, the positive terminal, negative terminal, positive terminal and negative terminal, which is connected in such a way that once the switch is on, what happens? The circuit will be complete, the flow of electricity, the current will be flows, and finally the bulb will be glows. Okay. And this is the inside view of torch, and the torch bulb can glows easily. Okay. And the last topic of the chapter, that is conductors. What are conductors? The materials which allow electric current to pass through them are conductors of electricity. What are the examples? Metals like silver, copper, iron, gold, aluminium, steel, etc. A few non-metals are also their exceptional case, like graphite is also conductor of electricity, even though it is a non-metal. Our human body is a great conductor, so that we will get electric shock. And the water means the tap water, except distilled water, the tap water, the pond water, the river water, sea water, rain water, this all are electric conductors because it has ions. Okay. And now the insulators. What are insulators? Materials that do not allow electric current to pass through them are called insulators. You know the examples of insulators you can see here. Let me ask you a question. Why do electricians wear rubber gloves while working? One of the most important items for electricians to wear rubber insulated glove which act as a barrier against electric shock. It protects the life of electricians. Or the same thing even we also can do when we are doing some electrical work by using tester or any other connection problem, or when you fuse bulb, if you make it properly, in that time also if you make insulators in your body means you never get a shock. You see that the handle of the tester is used to check the presence of electricity. So it is made up of insulators. Plastic is an example of insulators. Rubber plastics is a bad conductor of electricity. It will protect our body if you hold in the handle of the that tester, okay, which do not allow current to pass through them. So it protect electricians. Okay, only this part is conducting part. So the path of current is break from there, because here we are using what? A plastic. Plastic is a insulator. Okay, so that it can protect the life of a person as well as the life of electrician. Okay, and there are many safety measures in copper wire. Inside the wire it is copper. Copper is a conductor, but outside you can see the covering, the plastic covering. Why we are using plastic covering? Because plastic is a poor conductor. It protects it from getting electrical shock. If any breakage happens, what you have to do? You have to tie it with a plastic covering or any insulator. Okay, so inside copper wire is conductor and the outside coating is plastic covering, because the plastic is an insulator which will protect from the electrical shock. Look at here, iron box also. The covering body is the plastic body. Why? Or else you will get electrical shock if it covered with any metal or whatever things, if we made the outer covering of plastic instead of plastic. So that you must have seen the danger sign displayed on poles. It is a warn people because electricity can dangerous if not handled properly. Carelessness handling electricity and electric devices can cause severe injuries and sometimes even death due to electric shock. You may see that different death cases due to electrical shock, right? Yes, always you have to keep away from those, and you yourself should protect your body by wearing insulators. Okay, be careful with electricity, and always try to use insulators while we are working with electrical appliances, or while we are doing that electrical appliances works, etc. Okay, I hope you understood the topic. Okay.